we are going to be looking at how we can plot what we call the sine graph, or sometimes we call this the sine curve. So essentially what we're going to be doing is we're going to be putting all of the values of sine onto our usual xy coordinate grid. So we're going to have a pair of axes and we are going to show how we can plot the various points for sine. To do this, we are going to be using this unit circle once again. So make sure you are familiar with how this works. We know that this green length here is sine of theta, and we know that this yellow length is cos of theta, and this red length here is always 1 because it's a unit circle, it's a hypotenuse of 1. So we need to understand this picture. We also need to know the exact values that we've already worked out, because this is a really good starting point for drawing the graph. Without doing any extra work, we already have these 5 coordinates. So we have the coordinate 0, 0. We have the coordinate 30, a half. We have the coordinate 45, root 2 over 2, and so on. So this is a nice starting point. And in fact, I'm now just going to plot those coordinates. So we have that straight away. We have these 5 coordinates from the exact values. We have the coordinate 0, 0. We have the coordinate 30, 0.5. And we have the coordinate 45, root 2 over 2, which is approximately 0.7. So we have these points. And you can already start to see what the curve is going to start as. It's going to look a bit like that. Of course, it might be crazy in the middle. We don't necessarily know, but it looks like it's being a nice smooth curve going up that way. Okay, now I want to draw your attention to the axes here, because it's quite normal when we draw axes to have the same numbers along the x-axis and the same numbers along the y-axis. Now our problem here is that that would look really stupid for a sine graph, because our x values are normally a lot bigger than our y values. Our y values tend to be these small ones here. So we've got 0.5, for instance, here. But then our x values are quite big, so we've got 30, 0.5. So it wouldn't make sense to have what we'd call equal aspect here. It wouldn't make sense to have the same values on the x-axis and the y-axis. It makes a lot more sense to stretch out the y-axis so we can see more values. I want to be able to see 0.5 appearing, but also to compress the x-axis so that we can see the really big values. And you might want to immediately ask yourself why I've got this to show us between 0 and 360 degrees. Okay, so the point here is we've got a starting point. We've got the first 5 coordinates that will appear on this graph. I can use this picture to get a few more. So we've got to look at how the values repeat themselves. And of course, at the minute, we're only focusing on the green, we're only focusing on sine. Cos will come later. And we notice that actually, if we mirror these lines in a special way, the values do repeat themselves, or their negative versions repeat themselves, which, by the way, this number doesn't reflect the negative version. This always shows the positive version. So if I try to move this point so that I've got an angle of, there we go, this is 30 degrees. This is a 30-degree angle, and we've agreed that sine of 30 is 0.5. So that green line there is 0.5. But of course, that's not the only place that green line appears. If I go around here, so this is 180 minus 30 degrees now, this red line. So the angle from the yellow line to the red line, from our starting point to this red line, is 150 degrees. And we're getting the exact same value of sine. So sine of 150 degrees is 0.5. Let's have a look at this next one. So again, we've got another red line, we've got the same green line appearing. To get from my starting point all the way around to that red line is 180 plus 30, so 210 degrees, which means that sine of 210 is negative 0.5. The green line is the same length, it's still 0.5, it's the same length, but it's below the x-axis, so we're calling it negative. So this is negative 0.5. And then finally, this line here, to get from our starting point all the way around, is 330 degrees. So sine of 330 degrees is also negative 0.5. Now the point is we can do that with all of our exact values. So if I look at the most boring one, if I go right down here to 0, which see, the computer can't even cope because it is 0, but the computer doesn't quite recognize 0. We've agreed that sine of 0 is 0. If I go all the way around, I can now see that sine of 180 is also 0, because this is a 0 length. And then if we go all the way around again, I can see that sine of 360 is also 0. At the other extreme, I don't know if it's going to let me drag it out. No, it's not. There we go. At the other extreme, if we go right to the top end here, we agreed that sine of 90 was 1. Well, it looks like sine of 270 degrees is negative 1. So from our exact values and this picture, we can plot a few more coordinates onto the grid. And so this is now my second attempt. So for this one, all I've used my exact values, which were these first 5, but then I've added on the mirror images from the other picture to get these new values. So you can see the ones we actually looked at were sine of 150, which is here. Sorry, here. We agreed that was 0.5. We looked at sine of 210, which we agreed was negative 0.5. We looked at sine of 270, which is over here. There we go. And we agreed that was negative 1. So all the things we just agreed on are here, but you can do more. You can find all of these extra little coordinates. And this gives a really good picture of what the sine graph is going to look like. We can clearly see a curve starting to develop here. And if I actually enter that equation in, so I'm going to let the graphing software add this in, y equals sine of x, then you can see that it's going to go through all these coordinates and it's going to make a nice smooth curve in between. So this is what the sine graph looks like. It looks like this. We actually call it a wave. So it looks like this nice wave shape. And this is the main sort of body of the graph. It's between 0 and 360 degrees. And that's because it's the circle that we're basing it on. Now you may ask yourself, well, why is it doing, this graph seems to know something we don't, because it's gone beyond 0 and beyond 360 degrees. Well, with a bit of thinking, we can tell ourselves, well, once I've gone around the circle once, I can go around again, and again, and again. So actually, if I look at this third plot, where I've compressed the x values even more, so I can see a lot further, so I can now see x up to 1000 and something, you can see that the same little wave, so just to make it clear, this bit here, between 0 and 360, is what we were looking at a second ago. But actually it repeats itself after that. It does the exact same thing again and again. Because here we're just going round the circle. We are just going round the circle. So this is one turn of the circle, this is 2 turns of the circle, then 3 turns of the circle. We're just constantly going round the circle forever and ever. And of course we can do the same thing going backwards. We can go backwards round the circle, which is why we've got these negative values. The same thing is repeating itself for the negative values. We say that the sine graph is 360 degrees periodic. Now that's just a fancy term. Period is just the time in which it's doing something slightly different, and then it repeats itself after that period. So it's 360 degrees periodic because it repeats itself every 360 degrees. Right, so this here is the sine curve. You need to recognize it, you need to be able to draw it, and in the next video I will show you how we use it. The key points, of course, the key things to notice are the periods, the fact that it's going every 360 degrees, but also the maximum and minimum. So you'll notice that the graph never goes beyond 1 and it never goes beyond -1. The most that sine of something can be is 1, and the absolute least that sine of something can be is -1. And that is also going to be important to notice, that if you're trying to find the inverse sine of something bigger than 1, your calculator is going to give you an error because that's not possible. If we're trying to find the inverse sine of something, it has to be between -1 and 1. Okay, key points from this video. The sine graph looks like a wave. You need to recognize it, you need to be able to draw it. Sine graph goes between -1 and 1 on the y-axis. It can go between any values on the x-axis, but on the y-axis it is strictly between or equal to -1 and 1. And the sine graph is 360 degrees periodic. So it repeats itself every 360 degrees.